Hello everyone, good morning. My name is Mia. I'm super happy to be here. This is my first time in Vilnius and first time in Lithuania and first time in the Baltics, so I'm very excited. I'm a software engineer and also I'm vice chair of the European Society. And today my talk will be about Python. So let's start first with a question. How many of you are you looking forward to your next Python upgrade? Raise your hand. Okay, not so many people. And how many of you actually know what will be there? One person? Two? Maybe? Okay, two and a half people. I think there's some generally exciting stuff coming in the new Python, and these changes will affect how you write code. Unfortunately, most of us find out about Python changes when we start upgrading Python. Then we start, reading the documentation and figuring out what's new and what do we need to change. And it often happens that we actually have to upgrade just because we use some library that has some dependency or something like that. So we don't actually upgrade because we are interested in these new features or we are really excited about it and we want to try it out. But actually, we upgrade because we are sort of forced to upgrade. And then we get very surprised that something breaks. So here's one example. In 2020, there was an issue raised that multi-processing default POSIX start method of fork is broken. The key thing here is that this was raised in 2020. In December 2022, there was a public discussion about the issue where people just discussed various details about it. And in October 2025, the fix was released in Python 3.14. And this is a screenshot from the documentation. So you see there's a section porting to Python 3.14. And it says, this section lists previously described changes and other bug fixes that may require changes to your code. And right on the first place, you see that actually a method changed, so you are supposed to change it. And yet you could find rants on the internet like this one. In 3.14, among many other things, the Python developers decided to make fork server the default instead of the fork for the process method. Why on earth break our code in such a wanton way? Why not leave the default alone? There was always the option to use fork server if one wanted it. Or maybe they could have created a new entry point with a new behavior, process fast server, or some such. Oh no, just break it and make their customers patch furiously. When we adapt a language, we like to think that what runs today will run tomorrow. C and Bash programs that I wrote 30 years ago still run, not with Python. If you use it, buckle up and make sure your regression tests are through. It will be a rough ride. Move slow and break things, perhaps. So this was a rant from Hacker News. But the interesting thing is that actually Python, the most popular programming language in the world, is governed entirely in public. So that means that actually every decision, every debate, every rejection, every reason, everything is public. So it's searchable and there's absolutely no account or anything required. But most of us don't know where to look and where to find those things and what to expect when we are upgrading our Python. So this is one of many things that this talk is about. So we are going to talk about decision making, so how Python actually makes decisions. That means how an idea becomes a feature and how can you see that process yourself happening in real time. Then we're going to talk about the roadmap because there's one, it's just a few URLs, and once you know them, you will never be surprised that something changed. We're going to talk about features, what landed in 3.14 last October, and we're going to talk about some features that are coming this October because I do believe that some of those things are super exciting. And then we're going to talk about the community because some of the most important tools in your toolkit got built not by companies but actually by people who showed up and wrote those tools. And what any of this means to you, whether you're here just to learn to write better code or maybe to help to build the community around it, because there are more ways how to show up. So let's start with governance. How Python actually makes decisions. So for this, there are three bodies that have three different roles, and those three are most crucial. So there is the steering council, there is the Python Software Foundation, and there is the core team. The steering council, it's defined in PEP 13. PEP is a Python enhancement proposal. So there is one proposal which defines actually how does the whole governance work. If you would like to read it whole, basically it is a 5-person committee, and here you can see what are some things that they're working on. So maintaining the quality and stability of the Python language and C Python interpreter, then some things related to contributing, related to the relationship between the core team and the Python Software Foundation, decision-making processes for PEPs, because those are people who are actually making decisions what goes inside Python and what doesn't, and seeking consensus among contributors, and acting as a court of final appeal for decisions where all other methods have failed. And here you can see define authority. I think the most important this one for you is knowing that they are actually people who accept or reject PEPs. So there is a group, there's a committee of people who are actually deciding about those. There's one rule that I want to highlight because I think it really matters and super important, which is that there is a conflict of interest clause that says that no more than 2 members can be from the same employer. So what does it mean is that no single company can capture the technical direction of Python by just hiring enough of right people and having them run for the council. So it is an explicit anti-monopoly rule. So to make sure that actually the that the technical direction is governed by people who have experience and who are not biased. Um, Another part of this, which is very important, is the core team. So this is roughly around 100 people who have commit rights to C Python, and those are people who actually do the real work. So they write C Python code, they review pull requests, they merge code, they maintain the standard library, they write documentation, and so many more things. They also have one important democratic power, which is to elect the steering council. So people doing the work actually choose who are people setting the direction. And you can become a core developer by contributing over time when then existing core developers vouch for you, and they have to create a vote, and it needs 2/3 of positive over a week-long vote. And if you're interested in the topic, I can totally recommend this talk by Savannah. This was a keynote at EuroPython 2025, and she talked about all different ways how you can contribute. So some of them are obviously technical, and some of them are also non-technical, which are also interesting and important. And she also shared her personal story, how she got into it. So if you are interested, I warmly recommend it. And the final body I would like to mention is the Python Software Foundation. So it is an American nonprofit that has existed since 2001. Its job is separate from the technical direction, and this is intentional. So what they do is that they hold intellectual property, trademarks, funds Python OS, so all this sort of infrastructure around it. Also gives community grants to Python events and helps with projects around the world. And it's governed by a board annually by PSF members. So basically, they don't do the technical stuff, but they do the infrastructure around it. So now let's walk through what actually happens when someone wants to make a change in the language. So how an idea becomes Python. There is the PEP process for it, and I'm going to show you an example. So normally the first step is to post on the ideas category in Discourse if you're not a core developer. So Discourse is a forum where all things related to Python development are discussed. It is public, it is searchable, you don't need any account or anything. And as you can see here, this is the ideas category. So here you can discuss your ideas, or you can see all ideas that are discussed and what kind of thoughts people have on them. Then the second part is to find a sponsor if you're not already a core developer. So someone with commit rights who knows Python very well has to vouch for the proposal and to shepherd it through. This is just a quality filter, so the process isn't actually flooded with noise. Once there's consensus in the ideas discussion, the next step is to write a PEP and open a PR. So here's an example of PEP 758. And PEP is just an RST file, so you can open the pull request there, and PEP editors then review it for structure and completeness, so not content but format themselves. And then it gets a number and goes live at peps.python.org. Another step then is to post on Discord, and there is a public discussion. Sometimes scope needs to be refined, sometimes some details need to be discussed, and after discussion or refinement, and there can be multiple rounds of it, the author asks the steering council to make a decision. And step number 5 is decision. So the steering council debates it and posts the resolution of their decision in the same thread with reasoning. And it's also linked permanently to the PEP's resolution field. So for example, if you are interested why something in Python works the way it does, you can also, from PEP, you can also link to the resolution part and see the reasoning, or for example, if something is rejected and you're not sure why. And the final step is implementation merge into CPython. So the author opens a pull request, it gets reviewed, it gets approved, it gets merged, and the what's new documentation gets updated in the same PR. Now let's talk about the schedule. Python ships on a schedule, and as everything is defined in PEP, so is the annual release cycle. It is defined in PEP number 608. It was accepted in 2019, and right in the abstract you can see that every feature version is released predictable every 12 months. It is in October every year. So now you might be wondering, how does a full development cycle look like? Well, the development usually takes around 17 months, and we can go now through each phase. So the first phase is pre-alpha. It starts when the next version goes into beta. So for example, right now we are developing 3.15 in May. 3.15 goes into beta in May, which is 4 weeks from today. And this is the feature freeze. Then we make a 3.15 branch. Only bugs and docs changes are allowed. And in May becomes 3.16. Then there is alpha phase. Usually there are 2 pre-alpha and alpha versions. During this time, features can be proposed, accepted, and merged. And this window is usually open for 5 months. Alpha is 7 months with 7 alpha releases, and this window stays open for around 12 months. Then once beta 1 comes, there's a feature freeze. And from that point on, no new features go in, so it's only bug fixes. Fun fact, the beta phase traditionally falls in late May, just after PyCon US. The reason why is because there are sprints at PyCon US, and it's the last chance to get some significant work done. And the whole beta phase runs roughly 3 months with 4 number beta releases. Then it ends up in 2 planned release candidates, and then there is final release with full bug fix support. The final release goes out every October, and there's one fun fact. You might be wondering, well, why actually October and why not, I don't know, May or January? I heard that October was chosen as that's the month Monty Python first aired on BBC. And what happens afterwards is, since 3.13, there are 2 years of full bug fix and 3 years of security fixes. For version 3.12 and earlier, it's 1.5 and 3.5 years of security fixes. If you're interested in the release topic, you can check out this video. I will share the slides later with you. I interviewed 3 Python release managers last July, and they talk about the whole release process themselves. So now you might be wondering, well, where are we now and what is important for me to know? So this is the dev guide versions table, and it is a symbol table that's showing every Python version. It shows what is its status and what is its end of life date. So you can see when it's red, it means it's end of life. And when it's green, it means that it's already released and it's bug fix status, and then yellow means it's security only. So three things that are important to know right now is that the latest major version is 3.14. It was released last October. It is in bug fix status now, and end of life is in October 2030. So this is what you should be running in production if you are on the current release. Then there is Python 3.15. It is in alpha right now. Beta is at the beginning of May, and its release is in October. We'll look at its interesting bits in the next section. And when it comes to Python 3.16, there's PEP that's already failed, but development hasn't technically started yet, and the release is planned for October 2027. So, where can you actually find the current state of the release? There are a few URLs that I think it's super useful to have it saved. The first one is dev guide. So this one replies to the question which Python is stable, which is in development, which is in security only mode, and when everything reaches end of life. So this is basically from the screenshot that we just looked at. Then if you want to know why some feature works in the way it does, this is the answer. Here you can find every PEP ever written, whether it was rejected or it was withdrawn or accepted or in the draft state. You can search it, filter by status, and read the full reasoning basically behind it. And they're mostly for big changes, things like new syntax, new models, and other big things. If there's something super small that just needs a PR, then usually it just merged. And the what's new documentation, so there you can find what's changed, the why it changed, and what you should know about it if you're actually upgrading. And on top of each page there is the porting section, which is the one you have seen, and this is what you should read before you bump a Python version, so you actually know what are the breaking changes. So speaking of what's new, what's actually new in Python? So let's start with Python 3.14. One of very interesting features that got shipped was T-strings. They are similar to F-strings. They became super popular. I'm pretty sure that most of you have already seen it. However, there is one small problem with them. So you can have a look at the example. Here we have a variable user ID 1 or 1 equals to 1. And we have here a query, which is an F string. And if we actually print it, we can see that once everything is assembled, the result is just a plain string. So there is no way to inspect what came from where. And what does it actually do is that 1 or 1 equals 1 is always true, so that means that actually this means like return me every row. And this is fine if you're printing, but it is dangerous, but the string gets to some place that interprets it. So for example, a database or HTML renderer or shell command or similar. Which is basically a SQL injection attack. I'm pretty sure that all of you know this XKCD comic. Hi, this is your son's school. We are having some computer trouble. Oh dear, did he break something? In a way, did you really name your son Robert Job Table Students? Oh yeah, Little Bobby Tables we call him. Well, we've lost this year's student records. I hope you're happy, and I hope you have learned to sanitize your database inputs. And another problem is cross-site scripting, which is basically a type of injection in which malicious scripts are injected into otherwise trusted normal websites. So here, for example, you can see a self-retweeting tweet that has 83.5K of retweets. The safe way and how you're supposed to use it is to use parameterized queries. So in this way, SQL gets separately from data. The database compiles the SQL first, logs the structure, and then slots the value in, at which point it's treated as a data, not as a code. However, I've seen cases myself of F strings still being used instead of parameterized queries, so this is a concern. So what does a T string do? How is it different? Well, it looks like an F string, so here you can see this is the same example. However, it produces a template object. It doesn't produce a plain string. And the template object consists of strings and interpolations. So here you can see a string and you can see interpolation, which is basically the user input. So the static text and the interpolated values are kept separate, and this gives library authors a way to inspect what's code and what's data before deciding what to do with that. No major ORM or templating engine ships T-string support in production today. However, typically the language updates first and then the ecosystem follows. So the same as we have seen with 3. With F strings in 3.6, it will probably happen the same with T strings too. And here you can see we actually print it. We have static text and we have the variable which is separate. If you want to try it out, there's a playground with examples. There are lots of examples there, so you can just run it and see it yourself. Another interesting feature that landed is related to type hints. Type hints are also super popular, they're everywhere now, but there's one problem with them. So let's see an example. Here we import a data class and optional, and we have a data class which has a value, and the next one is it reference itself. So those are self-referential types. So this is basically like a linked list. And if you try to run this one in 3.13, what happens is actually there's a name error. That node is not defined. So what people usually do, the workaround is just to put the type in a string. You have probably seen this many times. I've seen it as well. A lot of code bases also added from future import annotations at the top of the file, but this is not a very nice solution, more of a workaround. So in 3.14, annotations are not evaluated until they are needed. So this is the very same code, but as you can see on the line 9, there is a self-referential type, and it just works. Nothing crashes anymore. Another super interesting thing that everyone is talking about is free-threaded Python. It is a very long story. Just a small note, if you don't know what is the GIL, because this is something what we'll be talking about. The GIL is the global interpreter lock, so it's basically a lock that says that only one thread can execute Python code at a time. If you have some I/O bound work, for example, some database queries, some network calls, reading files and stuff like those, it doesn't really matter because the GIL is released. But the problem is if you do lots of CPU bound work, so things like data processing, image manipulation, or anything like that. So the GIL is the bottleneck basically, and that's why people say that Python is slow. So Python 3.40 made the free threaded build officially supported, so we can have a look how it looks like. If you want to try it out, you install it separately as 3.14t. It has its own ABI. And here we have a simple function called multiply. The only thing that it does, it actually, we have a very large range and it multiplies some number just to heat up my CPU and do some work. Here, basically, we just basically check what's the time, how long does it run, and if I run it with the 3.14, like a regular one, here we can check if GIL is enabled, and we can see that GIL is enabled. This is the very same code, and with one thread it's 1.93 seconds on my computer. With 4 threads it's 7.48 seconds. Now here I'm running it with 3.14t, as you can see. So this is another build, and here you can see that GIL is not enabled, and this is the very same code. And here one thread is 1.77 seconds and 4 is 2.40 seconds. The previous one was around 7 seconds, so you can see that it's significantly faster. So what does it mean to you? Which packages are ready to use free threading? Well, this mostly affects libraries which are written in C. Lots of them were assumed that GIL exists and that it will be there forever, so that means that they're not threads saved without it, and you can just turn it off. If you want to know which ones you can use, there's a tracker for which packages are ready. So there is a Python free threading guide with explanation, what it is, everything. And it says here that you should start experimenting with free threaded Python once the libraries you depend on advertise support for free threading. See the tracking table for more details about the status of free threaded support in Python libraries. And if you click on the tracking table, so you can find a table like this one, and you can see what is the first version with support, which I think can be very handy. For example, you're picking which library you would like to use, and you have multiple similar libraries, then you can check out actually if it supports free threading. Um, Another interesting feature that will actually land in October, so now we are moving to Python 3.15, is lazy imports. So let's start with the problem. Every time Python loads a file, it runs every import at the top, even if that import is needed in just one function that you very, very rarely use. If you have a small script, this doesn't really matter, but if you have a large application with dozens of dependencies and each one has its own dependencies, then it adds up. So the workaround the developers have been using like forever is just to import a library inside a function. That way it doesn't have to be important every time. But this is not a very nice solution because then you don't have all the imports at the top right. So Python 3.15 adds a lazy keyboard. All imports can stay at the top where they belong, but they don't run until they are needed. Why is it? Well, so it's faster. So how faster is it really? So here there's a graph with moving average, which is those blue and those orange lines. The blue line is with regular imports, which is how it works now, and the orange line is with lazy imports turned on. And you can see that it is significantly faster. So it went from 104 to 36 milliseconds. So it's around 3 times faster. Another super interesting thing that is also very popular nowadays is JIT. So Python has had a JIT compiler 6.3.13, and it was big news all over the internet. If you googled it out back then, you could have found so many news and everywhere. For those who don't know it, just mentioned that normal Python interprets code line by line, but the way JIT works is that it catches what runs repeatedly and it compiles those hot paths into native machine code. This compiler that was there was mostly experimental. Some of you might have tried it, and you might have noticed that in some cases it was even slower than the interpreter. And Kenjin, the core developer who leads the optimizer, wrote in July 2025 that the JIT was often slower than the interpreter. So there's a section called Could Be Improved, the performance, and says, C Python's 3.13's JIT ranges from slower to the interpreter to roughly equivalent to the interpreter. Calling a spade, C Python's 3.13's JIT is slow. It hurts me to say this considering I work on it, but I don't want to sugarcoat my words here. The argument at the time was that it was a new feature and we needed to lay the foundations and test the waters. You might think that surely CPython 3.14's JIT is a lot faster, right? In some ways, the JIT has become faster, but only in select scenarios. The answer is again complicated. When using a modern compiler like Clang 20 to build CPython 3.14, I often found interpreter outperforms the JIT. The JIT only really starts reaching parity or outperforming the interpreter if we use an old compiler like GCC 11 to build the interpreter. However, in my honest opinion, that's not entirely fair to the interpreter, as we are purposely limiting in using a compiler we know is worse for it. And as some of you know, there was a team that was working on performance improvements in CPython. They were basically trying to make Python faster. And this team was funded by Microsoft. So what happened in May 2025 is that Microsoft canceled its funding. So this was one of the first actually messages that went out there. It's been a tough couple of days. Microsoft support for the faster CPython projects was canceled yesterday, and my heart goes to the majority of the team that was laid off. A hard day for me, but even harder for others. So lots of people were wondering what will actually happen with this initiative. And Kenjin, the main core developer, raised the idea of community stewardship publicly in discourse. So here he writes, Microsoft support for faster CPython is cancelled. It's been a tough couple of days. So this is what we have just read. I think it was a nice thing while it lasted. Just a recap, Python 3.14 is roughly 20 to 40% faster than 3.10. I want to thank to everyone who contributed. And he writes here there are three options. So one is to find another sponsor, which seemed very unlikely, especially if you remember all the layoffs and all what was happening back then. Shutting down the ongoing experimental strands of work and continuing with community stewardship. And the idea was accepted, the idea to continue with community stewardship, which was what actually he proposed. So the JIT team met at the C Python course sprint in Cambridge and they wrote a plan. They wanted to have JIT 5% faster by 3.15, so by this October, and 10% faster by 3.16 with 3 thread in support. So what is the current state of it? This is the state as of 1st of April, a few days ago when I made a screenshot, and you can see here that actually there is 6 to 7% geometric mean on Linux and 12 to 13% on Mac OS. And you can find it in the documentation. This is not final. So it says results from the Pi performance benchmark should report 6 to 7% geometric mean performance improvement for the JIT over the standard C Python interpreter built with all optimizations on Linux. On macOS, the JIT has 12 to 13% speed up over the tail calling interpreter with all optimizations enabled. The speedups for JIT builds versus no JIT builds range from roughly 15% slowdown to over 100% speed up. It is still opt-in, and those results are not final, as you can see, and the default Python 3.15 does not use JIT. And one of the most fascinating things to me is that actually the reason why JIT still exists is because of the community. The community decided that actually it was worth saving when it lost its corporate sponsor, and people just continued maintaining it and working on it in their free time because they believed in the project and they believed it's worth saving, even though it was not as promising as you could have seen at the very beginning. Which and here you can find this is just one part from the blog of the main developer who said, I cannot overstate how tough this was. There was a point where I was seriously wondering if the JIT project would ever produce meaningful speedups. To recap, the original C Python JIT had practically no speedups. 8 months ago, I posted a JIT Reflections article on how the original C Python JIT in 3.13 and 14 was often slower than the interpreter. That was also around the time when the faster C Python team lost funding by its main sponsor. I'm a volunteer, so this didn't affect me, but more importantly, it did affect my friends working there, and at a point of time, it seems that JIT's future was uncertain. So, what changed from 3.13 and 3.14? I'm not going to give some heroic tale of how we rescued the JIT from the jaws of failure to our acumen. I honestly attribute a lot of our success to luck. The right time, the right place, the right people, and the right bets. Which brings me to the next topic that actually I would like to talk about, which is the community. And I think the JIT actually isn't even the most interesting example of it because the JIT at least existed before the community had to step in. I do certainly think it's one of very interesting examples, but there are tools that were actually literally born at a conference and in a hallway similar to this one, and one of those tools is HPy. So just to explain what it matters, just to give you a short context, as you know, Python is slow at raw computation, and that's the reason why lots of data science libraries like NumPy and Pandas are actually not written in Python, but they're written in C. They're compiled to native machine code, and then they're loaded to Python as plugins. And those are called C extensions. So basically, when you write import NumPy on top of your Python file, you're loading a compiled C binary. And for Python, that binary to talk to each other, they need some contracts, so to exchange data, call functions, manage memory, and all those things that happens under the hood. So there's this interface for that, which is called C API. The C API in Python has existed since the 90s, so it's been there forever, and it was actually designed around C Python's internal, so the way how Python works. How Python counts references to objects in memory, where those objects sit, what their internal structure looks like, and everything. And that design created actually 3 problems that have been compounding ever since. So one is if you have some alternative implementation, for example, PyPy, you cannot run those cannot run your extensions because they manage memory differently, and they just have to fake CPython's internals just to load NumPy. The second problem is that CPython actually can't modernize in its own internals because there are thousands of libraries which actually depend on things being there. So if something would change, all those libraries would just break. And another problem is that those extensions are locked to one Python version. So this is why PyPI ships separate binary wheels for every Python version. So there's more maintenance, more CI matrix, and more things that can get broken every October. And there's HPI, which is a new C API. It does the same job, so letting C extensions talk to Python. So this is this sort of contract with the two. But it is designed to make as few assumptions about the internals as possible. So the result is that extensions that are built for it load unmodified on CPython, PyPy, GraalPython, because basically any sort of implementation that supports it. There are two buts. One is that it's still maturing. It's not really suitable for production services purposes, and most packages actually don't use it yet. But fascinating thing about this project is actually how it was built. And this is from one of the reports that says the idea of HPy was born during EuroPython 2019 in Basel, where there was an informal meeting which included core developers of PyPy, CPython, and Cython. So basically, there was a group of people who just met at a conference like this one in the same hallway, and they were just talking and they were discussing the pain points that all of them, as you can see, were working on different implementations of Python, and they said like, hey, let's just build something new, something that could work for all of us. And so I would like to talk a bit more about the impact of the community, and because I think that this is a part that might not be as visible. As you can see, there is big impact for the tech stuff. So sometimes community keeps some projects running, like the example of JIT, where actually people stepped up and started working on it in their free time, when they lost a corporate sponsor. And sometimes new projects appear just because people randomly meet somewhere and new ideas spark. As I've been involved in the community work for years, I would like to share some of my personal stories. Um, I've been around for quite some time. As Monica mentioned, I am based in Prague, Czech Republic, and we also have Python meetups. Our Python meetup is called Pivo, it means beer, and our logo is a beer glass with Python. We have one very interesting tradition. If you ever come to Prague, please ping me and come to our meetup. As you can see on the left side, there are shots that we take at the end of every meetup. It's not beer, it's shots. Some of them are green, which is like, it's called zelena. It's like a hard liquor, and some of them are actually juice because lots of people don't drink alcohol. That's okay too. And our meetups are just like regular people meetups for 20 to 50 to 80 people. And I started organizing it actually by accident. I used to go to those meetups because it was a nice way how to learn what's new in Python and what's happening, and just to talk to people. And once they said, we have no organizers, and if no one steps up, they're not going to exist anymore, and we are searching for new people. I was like, well, actually, I have lots of free time, so why not? Then I started organizing more things. Then I organized, this is Python Pizza. It's a one-day micro conference. It was one of my best organizing experiences because it's a small event and we organized it with a very nice and small team, and I got to meet lots of new people. Talks are 10 minutes long, so we had lots of speakers. I have been also involved with our Czech PyCons. This is from 2023. And that led me to EuroPython. I got involved when EuroPython was coming to Prague, which is in 2023. I started getting involved by just helping with some things here and there because they needed some, they had questions about how to do random, certain things in Prague. And, I was a local. I was like, okay, let me help you with that. And then I got involved more and more, and today I'm vice chair of the nonprofit behind it. So we organize EuroPython, the conference itself. This year we'll be in Krakow, and we also support other Python projects in Europe. And I've spent lots of time thinking actually what's in it for me, and actually what did it bring me in life, because I invest quite lots of time into organizing various things. And I think it helped me to develop lots of my new skills, and to learn lots of things like creative skills. For example, I learned how to make, I don't know, social media cards and things like those, how to do some basic design, how to write better, how to communicate better, lots of organizational skills, because obviously, you organize things, you organize them with people. So also some leadership skills, some building mental resilience. I also think it's a great way how to work on networking. I don't think it's that straightforward. People sometimes ask me like, "Oh, have you ever been offered a job just for being somewhere?" But actually, I got my previous job because the company I worked at for 3.5 years hosted a meetup, and I just went there because I was interested in the topic, and they mentioned that they are hiring, and I said, "Okay, I'm here." And I also got my current side gig that I work on, also because I met some people who recommended me somewhere. So I also think that actually events and being involved in community work are also a great way how to, expand your horizons, meet new people. Some of those people will be your colleagues, some of those people can be your managers, some of them will be your friend. And I think that's a really nice thing about it. That said, I made a short video. This was from PyCon 2023, where I asked other people actually what drives them to contribute to the community. So I would now like to show you this video. Let's hope that everything will work.
Hello, my name is Jan Gondol. I'm from Bratislava, Slovakia, and I'm one of the organizers of PyCon Slovakia. In the past, I worked a lot with open data, open education, open source software, open access to scientific publications. So basically, all things open. And the Python community is all about openness and sharing, and that's why I find it so attractive.
My name is Karolina Surma. I'm a PyLadies organizer in Brno, here in the Czech Republic, and I do it because I love the smiles of the people.
I'm Jan Pipek. I'm one of the organizers of PyData Prague meetups. And why do I do it? Because I love combining our very interesting field with the people, and especially in their free time, because in their free time they are their best.
Hello, I'm Sana. I'm a machine learning engineer in Prague, and I like contributing because there is literally no limits. You are welcomed by everyone, and you could be the next speaker at the next PyCon.
Hello, I'm Honza Javorek, and for many years I volunteer for Czech Python community. And I do it because first I wanted to learn more about Python. Then I loved the community, the people. I got a lot of stuff back from the people and a lot of opportunities and stuff like that. And now I do it because I want people to be able to learn programming easily and have it accessible.
Hello everyone, my name is Laisa. I'm a cloud engineer and I'm located in Munich. I was asked today why I organized PyLadies Munich. The reason is that in the beginning I thought I would bring positive impact to the community. After so many years, I'm sure of that. So be part of the community, volunteer, be kind to others. Thank you.
Hello, I'm Lumir, and I organize Pivo, PyLadies, and also PyCon in Australia and all around the Czech Republic. And what I love about the conferences is the possibility to share my knowledge and the possibility to learn from other people all around the globe.
Hi, my name is Paulina and I do Junior Guru podcast. It's podcast targeted on junior programmers or people who just want to start in the IT field. And why I do it, because the community helped me a lot when I was starting and I just want to give back, and also all the positive feedback just gives me the energy to do it.
Hello, I'm Anton. I come from Munich, I run an agency there and do tech events. Why am I doing it? It's a good question, really. I had to think about it. Probably first because I can, because I have a good team, but then there is a third and the most important part. Like, I moved to Munich 10 years ago, I knew nobody. We organized the meetup, we organized the conference, and then another conference, and then I think it was like 5 or something like this. And today I'm here in Czech Republic, in Prague, and I feel like home. I feel like this is my community and these are my friends everywhere. So I totally recommend to everybody to participate as far as you can.
Thank you for your attention.